All right, guys. Now we're going to identify even and odd functions algebraically. Now, it's best to say this. So, if you're doing a test and a function is even when you first test for even, then that is the answer. The function is even. If the test for even fails, then you must test for odd. And if the test for odd passes, then a function is odd. If the function fails the test for being odd, then the function is neither. So we have three different functions here. And we are going to determine if it's an even, odd, or neither. So remember, if a function is even, if f is even, then f of negative x equals f of x for all x in the domain of f. If it's odd, if f is odd, or g, doesn't matter, then f of negative x will equal to negative f of x. Okay, so I'm going to show you how to do it algebraically, and then I'm going to give you guys a little shortcut at the end. So let's first substitute negative x for x. So you're going to replace x with negative x. So we have f of negative x equals to negative 2 times, in parentheses, negative x being raised to the fourth power, plus 5 times the absolute value of negative x. Now let's take care of negative x raised to the fourth power real quick. That is negative x being multiplied by itself 4 times. So if you look here, two negatives multiplied makes a positive. Negative x times negative x is x squared. Same thing here. Negative x times negative x is x squared. X squared times x squared is x to the fourth. So I have f of x equals to negative 2 times x to the fourth plus 5 times. Now remember this from the first video of the test for symmetry. When it comes to the absolute value of negative x, any value that is negative inside the absolute value comes out as positive. And I can also write this as negative 1 times x inside the absolute value. X is arbitrary, which means it can assume any value. That's why it must stay inside the absolute value brackets. But when it comes to negative 1, any negative value inside the absolute value comes out as positive. That's why the absolute value of negative 1 is positive 1. The absolute value of x remains where it is. Therefore, the absolute value of negative x is equal to the absolute value of x. So that's 5 times the absolute value of x. So f of negative x equals to negative 2x to the fourth plus 5 times the absolute value of x. If you notice, this function, this answer here, f of negative x, is the same as the function f of x. So f of x equals to f of negative x. If f of x equals to negative f of x, then the function is even, according to this rule right here. That could have written better, but hey, everybody knows my handwriting is trash. So it passed the test for even. So that is it. Test for even is over. This is an even function. Now we're going to do the next one. So what we're going to do is to use the definitions up here. So we're going to find g of negative x. So we're going to replace x with negative x. So we have 4 times negative x, in parentheses being raised to the third, times, well rather minus, negative x. So negative x to the third is negative x times negative x times negative x. A negative times a negative is a positive, and a positive times a negative is going to be a negative. X times x is x to the third. So that's negative x to the third. So g of negative x equals to 4 times negative x to the third. And once again here, two negatives makes a positive. And that's going to be equal to negative 4x to the third plus x. Now, if you look here, this function, g of x, is not equal to g of negative x. Because g of x does not equal to g of negative x, g is not even. So we know the function is not even. Let's see if the function is odd. Now, to determine if the function is odd, we're saying that f of negative x must equal to negative f of x. So in this case, to see if the function is odd, g of negative x has to equal to negative g of x, which means we must multiply g of x by negative 1. So we know that g of x is equal to 4x to the third minus x. What we're going to do is we're going to multiply both sides by negative 1. When we do that, this gives us negative g of x equals to, distribute the negative 1 inside the parentheses, is going to be negative 4x to the third plus x. And if you notice here, g of negative x, which I'm going to highlight, g of negative x and negative g of x are equal to each other. Because these are equal to each other, the function is odd. So g is odd. F is even, g is odd. Because yes, this has been proven. G of negative x equals to negative g of x. And we're going to do one last one before I give you guys the hint. A little bit of strategy when it comes to polynomials, at least. So h of negative x equals to 2 times negative x being squared plus, in parentheses, negative x. A positive times a negative is a negative. So we have 2 x, negative x, the quantity of negative x being squared is going to be x squared, come out as positive. And it's going to be minus x. So 2x squared minus x. If you notice, this function does not equal to h of negative x. Therefore, h is not even. Let's see if it's odd. H of x equals to 2x squared plus x. We're going to multiply both sides by negative 1. So now we have negative h of x equals to, distribute here, there's going to be negative 2x squared minus negative x. If you notice, in this case, h of negative x does not equal to negative h of x, which means h is not odd. So h is not even, h is not odd, h is neither even or odd. And that is the answer to this question here, to number 3. So, number 1, the function is an even function. Number 2, the function is an odd function. Number 3, the function is neither even nor odd. When it comes to polynomials, if a polynomial has all even exponents, the function is even. Take that down and put in your notes. If a polynomial function, if all the exponents on the polynomial function are even, then the function is even. For a polynomial function, such as the second one, if all the exponents on the polynomial function is odd, because there is an invisible one right here, then the function is odd. And the last one, if the function has if the polynomial function has a mixture of even and odd exponents, which is here, it's 2 and 1, the function is neither even nor odd. So take that in your notes, run with it, and I'll see you guys soon. Take care.